Right, they've told us there's a line that goes through the points -2, 3 and 6, 9. And we have to find the equation of the line parallel to that goes through the point 5, -1. No problem. So first thing to do, plot the original line. So it goes through -2, 3, -2, 3 there, and 6, 9. 6, 9 is there. So it's something like that. Okay, I missed the point, but it's close enough. And we have to find the line that's parallel to that goes through the point 5, -1. The 5, -1 is there. Now, if we're looking for a line that's parallel to this that goes to that point, it's going to look something like that. They're parallel. They're meant to be parallel, okay? Now, parallel means they have the same gradient, which we write as m. So, if we can find the gradient of this line, we have the gradient of the new line. So, what's the gradient of this line? Well, gradient is rise over run. So we know it goes through the point -2, 3, okay, and 6, 9. So the rise is that and the run is that. So that's the rise, that distance there, and that's the run. So the gradient m is rise over run. And the rise, well, it's going from 3 to 9. So the rise is 9. The rise is 9 minus 3. Okay, that minus that is that distance there. The run, it's going from -2 to 6. So that distance there is 6 minus -2. 6 minus -2. So therefore m is 9 minus 3 is 6. 6 minus -2 is 6 plus 2, which is 8. Simplify, and it's 3/4. Okay? So, we found the gradient of the original line, and therefore we have the gradient of the new line. It's also 3/4, because they're parallel. Right, good. So now we just have to find the whole equation. Now, there are two equations which express the form of a straight line. There are two equations of a straight line, which you're probably familiar with. And they are y equals mx plus c, and also y minus y1 is m x minus x1, where x1, y1 is any point on the line. You can use either of them to solve this question. I'll show you both ways and you can pick your favourite. So let's start with y equals mx plus c. So what you do, y equals, we know the gradient is 3/4, so the equation of this new line is y equals m x plus c. And you just pick a point on the line that you know and use those values of x and y and sub it into this equation to find c. Well, we only know one point, and that's the point 5 minus 1. We know for sure that that point is on this line. So we take x is 5 and y is minus 1. So therefore, y is minus 1 is 3/4 of x is 5. Use brackets when subbing in, plus c. So now we've got one equation, one unknown, we can find c. So let's multiply everything by 4 to get the 4 off the bottom. So therefore minus 4 is 3 times 5 is 15, plus 4c. Let's bring the 15 over here, so subtract 15 from both sides. So therefore we get minus 4 minus 15 is minus 19 equals 4c. Divide both sides by 4 and we get c is minus 19 over 4. I forgot to mention that c is the y-intercept. So if we just extend these lines here, we've now worked out that this new line will cross the y-axis, in other words, the y-intercept, at minus 19 over 4. Okay? Anyway, back to getting the answer. Well, we've pretty much done it. Y is nx plus c. So therefore, let's do it here. The equation of the line is y equals, the gradient is m x plus c, and c is minus 19 over 4. Okay, so that's the equation of this line. We've found it, but the question asked us to put it in the form ax plus by is c, where a, b and c are integers. So it's not in that form yet because that's not an integer, neither is that. If you multiply everything by 4, then that's a good thing, because we get 4y is 3x minus 19. Ax plus by is c, so we've got to bring the y's over here and that over here, and we get 3x minus 4y, 3x minus 4y equals 19. That's right, 3x minus 4y is 19. Okay, and that's the equation of this line. Now, that was using y is nx plus c. We can also use y minus y1 is mx minus x1. These are two different forms of the same equation. They're essentially the same equation, just two ways of expressing a straight line. So let's do it using this one this time. Now, x1, y1 is any point on the line. And we know m is 3/4, so we get y minus, so we need a point on the line. Again, 5 minus 1. We know for sure that that point is on the line. So x1, in this case, x1 is 5 and y1 is minus 1. So y minus y1 is minus 1. Y minus minus 1 is m, x minus, and x1 is 5. Okay? That's the same as y plus 1. So multiply everything by 4 to get that off the bottom. So we get 4y, therefore 4y plus 1 times 4 is 4 equals, so that's gone now, 3 times x is 3x, 3 times minus 5 is minus 15. Okay, so bring the 4 over here, we're subtracting 4 from both sides, get 4y equals 3x minus 19, and put it in this form again. You need to bring the 4 over here, the 19 over here, so we get exactly the same thing. 3x is, we get 3x minus 4y is plus 19. Okay, and as we expect, we get the same answer. So that's it. A is 3, B is minus 4, and C is 19. And that's the equation of this new line. It doesn't matter whether you use y is mx plus c or y minus y1 is m, x minus x1. Generally, this one is probably better because it doesn't restrict you to working out where the line crosses the y-axis, in other words C. The great thing about this one is you can use any point on the line, generally. I realised that in this question we used a point that wasn't the y-intercept. We used 5 minus 1 here to work out C. I'm probably overcomplicating this. Generally, this one is probably the better one to use. That's what I'm trying to say, but it doesn't matter.